Welcome! NOAA has just released its annual Global Climate Report for the year 2019, and this video is a summary of its main conclusions. The main headlines for the year are that Australia and Alaska had their warmest years on record, South America and Europe had their second warmest years on record, the world's ocean had the second highest average sea surface temperature ever recorded, and we had above average cyclone activity in most of the oceans that form that sort of activity. We had massive wildfires in the Amazon, the Arctic Circle, and in Australia. Here is a plot of the combined land and ocean temperatures for the last 140 years. On the far right you can see 2019 in second place. That means we're already 1.1 degrees centigrade above pre-industrial levels. The linear fit that I've put on this graph is a rate of increase of 0.17 degrees centigrade per decade. Now I've chosen to do this over the last 40 years because that corresponds to the same period in which we have satellite observations, so I can compare those, as we shall see later. The worrying thing about this is if this trend were to continue, by 2100 we would be 2.5 degrees centigrade above pre-industrial levels. So we're pushing our climate into a completely new regime, one that has not been experienced by any animals or plants that are currently existing on this earth. And that's a very dangerous thing to be doing. Well, let's take a look how these temperatures are distributed around the globe. One of the things you want to do when you're looking at a map like this or a time history is to know what the baseline period is. In this case it's 1981 to 2010. If we look on that on the time history of the temperatures, you'll see that's a period of already enhanced global warming. The average temperature during that period is marked here. The normal thing that we compare this with is the 20th century average, which is down here. This map will appear to be about 0.4 degrees centigrade cooler than it would do if you were just dealing with the 20th century average. We have one area of cold, that's the northern tier states of the United States and some of the southern areas of Canada. But to compensate for that, we have very warm temperatures in Alaska, Central Europe, northern Siberia, Australia, and to some extent South Africa and South America. Off the west coast of South America, we have a mixture of both cool and warm water. That means that the El Niño-La Niña cycle is in a neutral phase. So there is no enhanced warming as a result of an El Niño or enhanced cooling as a result of a La Niña. None of that information on the temperature departure from average gives you any information whether those temperatures were record warm or record cold. To do that, you must look at something called the percentiles map. Now, first of all, again, you should look at the baseline. This baseline is from 1880 to 2019. The color coding on here is such that if you have a record cold pixel, it's dark blue, or a record warm pixel, it's dark red. As you can see, there are no record cold pixels or even any much cooler than average pixels on the 2019 map. However, there are hundreds of much warmer than average, and nearly 200 records have been set on various pixels around the world. So this would indicate that we have a strongly warming world, which is consistent with this 2019 being the second warmest year on record. Next, let's take a look at the upper atmosphere. We look at three main layers there: the lower troposphere, which has an average measuring altitude of about 4 kilometers, the mid-troposphere with an average altitude of about 7 kilometers, and the stratosphere, which is the odd man out in that it's cooling with an altitude of 17 kilometers. We look at the results primarily from two groups: the University of Alabama in Huntsville and Remote Sensing Systems. Now they look at the same data, they just analyze it in a different way with different assumptions. In the lower troposphere, UAH found it to be the third warmest year on record, and RSS found it to be the second warmest year on record. Between them, the average trend over the last 40 years is 0.16 degrees centigrade per decade, which is remarkably similar to the surface temperature, which is not surprising because it's relatively close to the surface. In the mid-troposphere, we find that the two groups find it to be the third and second warmest year on record similarly, but the average trend is lower, as you'd expect, to be 0.12 degrees centigrade per decade. The stratosphere, UAH found it to be the third coolest, RSS found it to be the sixth coolest, and they had a trend of minus 0.25 degrees centigrade per decade. Another record was set in 2019, which was the ocean heat content. That's the amount of energy stored in the oceans. From a depth of 0 to 700 meters, the amount of energy stored now is nearly 2 times 10 to the 23 joules. To give you some idea of how much energy that is 4 times the level of the reserves of energy we have in all the types of fossil fuels around the world. That's coal, gas, and oil. If you go down to 2,000 meters, that goes up to a factor of 6. That is approximately equivalent to 1 million of the largest nuclear weapons ever built. That is a very, very scary amount of energy, and you cannot deny that that would create some sort of problem with the weather system, and we are seeing those effects now. One of the big issues as far as climate change is concerned is sea level rise. So let's take a look at that. Here's a plot combining tidal gauges and satellite altimetry data, and you see they agree fairly well. And it shows that over the last 140 years we've had sea level rise of about a foot. Now, if this current rate of change of sea level is continued, by 2100 we will be somewhere between 30 centimeters and 2.5 meters in sea level rise, and both of those are very serious increases. Now let's take a look at the situation with El Nino and La Nina. If this index, which is the measure of El Nino, is above 0.5, then it is an El Nino. If it's below minus 0.5, then it's a La Nina, and anything in between is considered neutral. As you can see, we started off the year with a very weak El Nino, and we spent most of the rest of the year in neutral conditions, which is what's prevailing currently. The model seemed to be showing a distinct fall off in the index, and so consequently it looks as though we'll be heading for neutral conditions for the rest of the year, at least through the summer, and maybe even a La Nina by the end of the year. The situation with El Nino makes it all the more remarkable that 2019 was the second warmest year on record. Let's take a look at the El Nino La Nina considerations compared with 2016. Here is the warmest year on record with a very, very strong El Nino. Here is the second warmest year on record, and you can see it's a very weak El Nino shading over to neutral conditions. So despite that, there's only 4/100ths of a degree centigrade between the average temperature of 2016 and the average temperature of 2019. So that makes it very remarkable that this turned out to be the second year, and indicates just how strongly the planet is warming still.
For those that had some hope that the sun was influencing our climate, at least to produce global warming, 2019 was a very bad year. The sun was extraordinarily quiet during the year, yet we had the second warmest year on record. Currently we are in solar minimum conditions, or near solar minimum conditions, and we're beginning to see the swap over to solar cycle 25 with a few reverse polarity regions. The sun is likely to start its solar cycle 25 during 2020. We expect to see more sunspots and possibly even some flares towards the end of the year. Well, let's draw some conclusions from all of this. 2019 was the second warmest year on record. It was 0.12 degrees centigrade warmer than 2018 and only 0.04 degrees centigrade cooler than 2016, the previously warmest year on record. This was all achieved during an ENSO neutral environment as opposed to a strong El Nino, which is what was happening in 2016. The sea ice once again was below average in both polar regions. Solar activity cannot explain the warm weather we've been having. Solar cycle 25 has not started yet and probably will start sometime during 2020. 2020 will probably be slightly cooler than 2019 because there's a chance of a weak La Nina towards the end of the year. So until next time, stay safe. Goodbye.